Okay, so the last section we're going to look at this week is 1.2. We're going to start part of 1.3, but we won't finish that until Tuesday. So, first thing that they mentioned in this section is not even really specific to math, just kind of a general approach to solving any kind of problem. And that's breaking down, when you read the problem, what have they given me to work with, and what is it they want me to find? If you don't understand what the question is, or what they want to know, then you're definitely not going to be able to solve it. Okay, so that's the first step. What is it that they want me to try to figure out, and what is it that they're giving me to help me figure that out? Okay, once we've broken that down, the next thing is to come up with a way that we're going to solve the problem. When we get to doing trig, okay, a lot of times we'll draw a diagram. Okay. We'll talk about like opposite and adjacent and hypotenuse, and that's more of a visual thing. So it's better if you can visualize, okay, opposites here, adjacents here, you kind of need to see it. Another approach, sometimes when we're solving problems, we can make a list. Like if I said to you, using the letters A, B, and C, tell me every way you can arrange those letters. You could make a list, like ABC, ACB, BAC, and so on. But what do you think could happen with a list? Not necessarily with just the letters A, B, and C, but making a list could kind of turn into what kind of thing? Could be, yeah.
Take forever, it could be really long.
Yeah, it could end up being really long. If I said to you to take every letter in the alphabet and tell me every possible way you can use each letter once and arrange them in all the different orders you can arrange them, well, there's probably billions or trillions of combinations. So making a list isn't always practical. But one thing that we do for almost every problem, we're going to do this today, is making some kind of equation. Sometimes the equation is something we just have to figure out based on a word problem. Sometimes we have kind of a hint at the equation to use, like if it's a right triangle, maybe Pythagorean theorem would come up. If we were doing a problem about area and perimeter, we might already know the formula for that specific shape. Certain shapes you do need to know area, volume, and perimeter. The basic shapes. Okay, like I would expect for like rectangles, you know the formula for area and perimeter. If it was kind of a shape you don't use a lot, like a pentagon, I wouldn't expect you to know the area of a pentagon. I would give you something like that. Okay, so then once we decide what kind of method we're going to use to solve it, then we actually start solving it. So let's say you set up an equation. If it was a quadratic, now you have to decide how you're going to solve it. You're going to factor it, you're going to complete the square, quadratic formula, or maybe you're going to do a graph on the calculator. Okay, so then we have to kind of carry out whatever method we decided on. So any questions on those very general kind of concepts? So we're going to look at a problem that setting up an equation is going to be the method that we're going to want to use. And that's what they tell us in the directions. So we have a company that charges $15 to rent a car and 20 cents for every mile that you drive. So we want to set up an equation to represent this. First of all, how many variables do you think I'm going to need in my equation? Yep, Asher. Yeah, I'm going to need 2. Can anybody tell me what one of the variables would represent in this problem? Yep, Elise?
I'm assuming like the total cost.
Total cost. Yep, that's going to be 1. Yep.
How many miles traveled?
And how many miles traveled. Now, we're going to do a graph in a little bit, so I'm going to call those two things X and Y. And another term we'll get to in a little bit is independent and dependent. Does anybody remember looking at those two? Which one is the independent variable? Yep, Lauren?
The front
So would it be the x or the y?
The Y.
So the y, that's the total cost. That is our dependent variable. Okay, so y is going to be the dependent. Because the way you'd say that is the cost to rent the car is dependent on how many miles you drive it. Cost is dependent on miles, not the other way around. Miles isn't dependent on cost. Like you're going to rent the car, you're going to drive however far you got to drive, and then when you're done, your bill is going to depend on how many miles you drove. So the cost is dependent. So the number of miles is called independent. All right. So starting with y equals, anyone think they could give me an equation that would represent this situation? Yeah, Jake?
0.2x plus 15.
Yeah, 0.2x plus 15. So that's the equation that represents our problem. Questions on that? Yeah, just sign out. All right, now I want to use that equation to figure out the cost to drive 50 miles. So how are we going to use that equation and the 50 miles to figure out the cost? Yeah, Kelsey?
Insert 50 where X is.
Yeah, we're going to plug in 50 for x. So cost is 0.2 times 50 plus 15. 0.2, if you think of it as a fraction, that's 1/5. So what's 1/5 of 50? 10, and then plus 15 is 25, which should be my label on that. Yeah, dollars, yep, good.
It'd be really nice if renting a car cost that much.
Yeah, that'd be pretty cheap. Now, how about 100 miles? Can I just say, well, it's double the mile, okay, double the cost. It's going to cost me $50. What do you think? What do we think about that? No? Why not?
Because the 15 doesn't change depending on how far you drive.
Right, you don't want to double the 15. You only want to double the mileage part.
Yeah.
Okay, so we got to figure that out again.
35.
Yeah, so it's going to be 0.2 times 100. 0.2 times 100 is 20, plus 15 is $35. Okay, any questions on that? All right, so that equation that we came up with, that 0.2x plus 15, okay, that's called the algebraic representation of the problem. Okay, if somebody were to walk in here right now and look at that equation, they'd have no idea that this is about renting a car that's 20 cents a mile and $15 is like the initial cost. Okay, by writing that equation, we kind of taken all that information out and reduced it to just an equation. So if they ask in the homework for an algebraic representation of a problem, basically means write an equation. So now, using that same equation, let's do something a little different. Let's suppose that Sarah was charged $50 to rent the car. I want to know how far she drove. What's a little different here than the last two examples? Natalie?
Plugging in for Y.
Right, now we're plugging in for y, and it's more of algebra because we're going to solve and get the variable by itself. Okay, so let's plug in 50. So I'm going to fill in 50 where I just circled. Okay, so we got 50 equals 0.2x plus 15. Okay, so we'll bring the 15 over. And remember, 0.2 is 1/5. So instead of dividing by 0.2, I could multiply each side by what?
Is it 20? Or
No, 0.2 times 20 wouldn't cancel out and become 1. So we're trying to cancel out that 0.2, so it turns into a 1.
5.
5, yep. So multiply each side by 5. 5 times 0.2 is 1, so now we have 1x. And 35 times 5 is? Yeah.
175.
Yep, and what is that? 175 miles. Okay, so algebraically, that's how you can solve that one. So let's look at how we could do it graphically. Okay, on the calculator. So on the calculator, we're going to turn it on. In the upper left, you're going to press y equals. If you already had anything that's in there, we're just going to clear out any other equations so that the screen looks just like that. Okay. Does everybody's screen look just like that? So what we're going to do is we're going to take this side of the equation. We're going to put that where it says y1. I'm going to take that side of the equation, and we're going to put that where it says y2. So we're going to type those two things in on the calculator. So we're going to put 50 on y1 and 0.2x plus 15 on y2. So now we're not thinking as these of equations anymore. We're going to draw two pictures on the screen. And we're looking for where the picture we draw in y1 is equal to the picture that we draw in y2. What does that really mean? If we're looking for where two pictures are going to be equal to each other. Yeah?
They will wrap.
Yeah, we're looking for where they intersect each other. And these are both lines. The one on the right is y equals mx plus b. It's got a y-intercept at 15 and a slope of 0.2. What kind of line is that on the left? Y equals 50. Yeah?
It's just a horizontal line.
Just a horizontal line at what number?
50.
50. So if we do a standard window, which is negative 10 to 10 on the x and y, are we going to see anything? No. We got to go way past that. In fact, we already know how far we have to go on the x-axis. We have to go out all the way to 175. But let's say we didn't know that. So let's look at our window. X is mileage. What's the lowest number of miles that would make sense in this problem? Yeah?
Would it just be 175?
So you couldn't drive the car any less than 175 miles? I mean, could you drive the car like 30 miles if you wanted to?
I mean, you could, but
You
that's
could.
the outcome of it.
Right, we don't know that.
Oh.
So we don't know that answer yet. We're just thinking in this word problem, what's the lowest number of miles you could potentially drive the car? Yep.
0 or 1 then?
Yeah, I would go with 0. Yeah, we can't drive negative miles. So in this problem, it doesn't make sense to keep that at a negative. And now, I guess potentially the cost, if you decided to not even call and rent the car, you know, you'd pay nothing. So we could put that at 0. Now that y equals 50, we said earlier, that's a horizontal line at 50. So let's set our y max to at least that high. And I don't want it right on the edge of the screen, so let's do a little extra. Let's do 60. Well, when we graph it, we definitely can see the horizontal line. And we're starting to see the line that has a slope of 0.2 and a y-intercept of 15. But I'm looking for where they cross. What value in my window do I need to set higher? Because I can't see where they're crossing. Yeah?
X max.
Yeah, the x max. Okay, and if we didn't already know it was 175, we might have to play with it until we find a number. Again, so the intersection isn't right on the edge of the screen, I'm gonna do 200. And now you'll be able to see where they cross very clearly. All right, now what we want to do is figure out where is that point, okay? And the calculator can tell us that. Yes?
I'm getting an error for invalid dimension when I have the exact same thing you did in the line.
The invalid dimension? Yeah, let me see. It's probably because one of the scatter plots is turned on. Yep. You're all set. You're welcome. So something like that I would help you with on a test because that had nothing to do with anything I taught you. So you wouldn't have known how to fix that. At least I didn't teach you how. Okay, anybody else? No. Okay, so if you press trace, hey, you can kind of move your cursor till you get closer and it's giving you the coordinates at the bottom. So you can kind of estimate it, but we don't want to estimate it. We want to get an exact answer. So to figure out where these cross exactly, you're going to press second, and then you're going to press calc. Okay, it's the button right above the word trace. We're trying to find where these lines cross. So which option do you think we're going to use? Yeah.
Intersect?
Yeah, I'm going to use intersect. So when you press intersect, it's going to ask you 3 different questions. First, it's going to ask you to pick a point on the first line that you're using. Then it's going to ask you to pick a point on the second line. And the reason it does that is because if you had multiple lines on the screen, like 3 or maybe 4 or 5, the calculator can find one intersection point at a time. So you have to tell it which 2 lines you want to use. The blue and the red and the black, which 2? Well, we only have 2. So where it says first curve, just pick a point anywhere on the blue, doesn't matter, hit enter. Pick a point anywhere on the red, doesn't matter where you put it. And then the third thing it asks you for is a guess. The guess has no effect on it in this problem. So you can put the guess, if you want to move the guess close to the intersection point, you can. If you don't want to, you don't have to. It won't make a difference. Just hit enter when it says guess. And it tells us, scroll down, that the intersection point is when x is 175. And that's exactly what we got algebraically. Okay. So any question on finding that intersection? So I don't want to get into it a lot, but if you're wondering, well, when would the guess matter? If I did something like this, and again, just watch me do this. How many intersection points does the blue and the red one have now? 2. The calculator can only give me 1 at a time. So when I want to do an intersect, I need to say, okay, I want to use the blue one. I want to use the red one. And now, wherever I put the guess closer to, that's the intersection point it will give me. If I want the one on the left, I need to move the guess closer to the one on the left. If I want the one on the right, I need to move it closer to the right. It cannot do both at the same time. Okay, so now if you want the right one, you've got to go through and do it again. That's what the guess is. Any questions on that? Okay. So you're going to see in the homework, on a test too, directions that say find a window that basically shows a complete graph. A complete graph is a window that shows everything that's important. So for our last problem, I would say the most important thing was the intersection point. If the intersection point is off the screen, that's not a good window. If I'm looking at this problem, and I'm trying to find where that horizontal line crosses the parabola, I would say that's a good window. That's a complete window. I can see everything I need to see. If I had this as my window, now I would say that's not a good window. It's a parabola, but I can't even see the other half of the parabola. Okay. So there isn't necessarily one right answer for a complete window. Okay, there could be more than one answer. Other things that are important features, sometimes you want to be able to see where the graph crosses the x and the y-axis. Okay? If that's what you're focusing on, you need to make sure your intercepts are on the screen. And the way you describe a complete window is you just write it down. Okay, so remember, 4 values you need to write down when you're describing a window. The x min and max and the y min and max. Those are the 4 things I would be looking for. All right, so let's try finding a window for this one. I think we did this one, maybe. It was one of the first problems I might have shown you yesterday when we talked about finding a window. I can't remember. Let's type in x squared plus 10. Actually, I already have x squared typed in, so I'm just going to put it on y2. You can put it on y1. It doesn't matter where you put it. And let's do zoom. And what did I say the zoom you usually want to do is if you're not sure where to start? Yep.
C squared
Or standard.
Standard. Yeah, so the 6th one down. That's going to set your window -10 to 10 and -10 to 10. Okay. So would that be considered a complete window for x squared plus 10? No, I can't even see the graph at all. That's a horrible window. What needs to be adjusted here so I can see the parabola? Just one number needs to change.
The y minimum,
Okay, what do you want to set the y minimum to?
-20.
-20? Okay. All right. Still don't see it. Anybody have another thought? Yeah?
The y maximum.
Okay. What do you want to set the y maximum to?
30.
All right, let's try 30. Yeah, and that works fine. Is 30 the only answer? No, you could probably do 20, 30, 40. What I wouldn't do is like 40,000. If you do 40,000, it's going to make that parabola look so squished you won't even see it. So that, I would say, is a perfect window. Okay, so just write down the x min and max and the y min and max. That's all you need. I think we mentioned that yesterday, but that kind of graph, when you draw a quadratic, that's called a parabola. Yes?
So when I get a question asked for the view in rectangle, that's, I just set the window and,
You tell me what you used. Yeah.
Okay.
Just tell me, yeah, just write down what you used. We'll talk more about quadratics, but in general, x squared plus 10 is kind of a really simple quadratic. But it is a quadratic. Let's try this one. Square root of x plus 20. All right, so if you're not sure where square root is, I'll show you how you get to that. You press second, and then it's the x squared button. That's how you do square root. Now, we learned about different kinds of numbers, and I said for now, we're sticking with the real number system. So when you have a square root, forget about anything like x plus 20, just any square root. Whatever you put underneath it, if we're dealing with real numbers, has to be what kind of number? Yeah.
a real number?
No, there's some real numbers that if you put under there, we're gonna have a problem. We're gonna get imaginary answers. So we gotta stick with certain kinds of real numbers under here. Yeah.
Is it even number, or not even, positive?
That covers most of them. Yeah.
Whole numbers?
No, you can take the square root of decimals. Decimals are okay. Like you can do square root of 2.3. So we were closer with positives. But there's something else you can take a square root of that's not positive. Yeah.
Integers?
So again, you can, no, certain integers would run into a big problem here. If you try to take the square root of -3, we're going to have not a fun time if we're dealing with real numbers. Yeah.
Perfect root?
What is it?
Perfect root?
No, you can take the square root of like 7. You'll get a real answer. It's like 2 point something. So decimals are okay. Yeah.
All the positive numbers?
And what else? Yeah.
Not 0.
You can do 0. So you could take the square root of any number that's not negative, which is not the same as saying positive. Okay? Positive would not include 0. You can take the square root of 0. So whatever you put under here has to be 0 or higher. You can only take the square root of something that comes out 0 or higher. So this needs to come out 0 or higher. X plus 20 has to come out to be 0 or higher. So what does that mean x has to be? If x plus 20 is greater than or equal to 0, what does that mean about x? Yeah.
It's be greater than or equal to -20?
Yes. X has to be greater than or equal to -20. That's important because it's going to help you to set your window. We now know how low of a number we can plug in for x. If you go lower than -20, it's not going to work. If you plug in like -21, -21 plus 20 is -1. You can't take the square root of -1 when you're dealing with real numbers. I was going to show you, but I guess I'm not. Second, square root, square root. Can't take the square root of a negative number, at least, and get a real answer. All right, so we know we can go as low as -20, and I like to go a little bit past it, so I'm just going to do -25. And how high we go, well, you can go as high as you want. You could plug in 4,000 for x, add 20 to it, and then take the square root of 4,020. So there is no upper limit, okay? Since it keeps going forever, we got to set the window to stop somewhere. So I would say 100 is probably pretty good. Now, if you were to plug in 100, 100 plus 20 is 120. What's the square root of 120 pretty close to? Yeah,
My 11?
that's pretty close to 11. So that's about as high as you're going to need to go. I'll go one extra. But your y value, if you go up to 100 for x, you're not going to go above 12 for y. You're only going to go up to about 11. And that's a good picture of a square root. A square root is basically, it's a parabola on its side, but it's only half of it. It's not both halves. So find a complete graph. I would say write down those mins and maxes for x and y. That's all I'd be looking for. So we'll talk more about it, but there's two kinds of functions you got to be careful with. Square roots are one of them. There are certain things you are not allowed to do. And fractions with variables in the bottom. Because if I wrote this, there's a number that you should not be filling in for x there. Because if you do, it's going to cause us to do something we're not allowed to do. What number can you not fill in for x?
3.
3, yeah. So when you're dealing with square roots, you've got to make sure that what's under the root is 0 or higher. And when you're dealing with fractions, you have to make sure you never end up with 0 in the bottom. Okay, people mix that up. Like they start thinking you can't take the square root of 0. The square root of 0 is okay. Dividing by 0 is what's not okay. All right, let's take a look at the last part for today. So going back to that rent-a-car problem, when we did the rent-a-car problem, I asked which letter is the input and which letter is I asked which letter was the independent variable and which one was the dependent. And I told you that the x is always the independent variable. Y is always the dependent. Okay, well there's a few different names for the x and the y. Okay, another name is the input and the output, or the domain and the range. And we're gonna talk a lot about domain and range. Now, there's a lot of different graphs you can do. You can draw lines, you can draw parabolas, but not every graph that you make is what's called a function. Okay? Some people learn what is and what isn't a function using something called the vertical line test. Well, the vertical line test is okay, but if you were ever taking like a higher level math class and you had to justify if something was or was not a function, using the vertical line test is not a justification. It's not. It's kind of a algebra 1 kind of thing. Okay? This is the real definition of a function. Okay? A function means that for every x value you plug in, you only get one answer in the output. So here's an example of something that is not a function. Y equals positive or negative square root 25x. If I plug in 1 for x, what's 25 times 1? 25. And then what's the square root? What's the positive square root of 25? 5. And now if I plug in 1 for x, multiplied by 25, I get 25. What's the negative square root of 25?
Negative.
Okay. So that is not a function because you had an input value, 1, and it gave you 2 different outputs. You're supposed to have exactly 1 output, not 2. Okay, so that would fail the vertical line test if you drew it because it has 2 outputs. All right, so any question on that the definition? Just another way of saying what I've already said to you. The domain, that's everything that you are allowed to plug into a function. The range are all the answers that you get when you plug those numbers in. And the only functions that are a little bit tricky to find domain are square roots and problems where you have a fraction with a variable in the denominator. You have to be very careful when you're dealing with those 2 functions. But in general, domain is pretty straightforward to do by hand. You can usually figure out domain. Range is a little harder, and we'll usually use the calculator to help us to visualize what's happening. As I said before, we're sticking with real numbers, so we are not allowed to plug in imaginary numbers for x at this point. Just reals. Okay, when you write a function, that's one way to do it. That's how we did it in the rent-a-car problem. But there's something different that you can put here besides y. Does anybody know the other notation I'm thinking of? Yeah?
F of X.
Yeah, f of x. So f parentheses x is just another notation that means I have a function named f, and it uses the letter x as the independent variable. That's exactly what that means. You could also have a function named g that uses the letter x as the independent variable. And then you have to write something down on the other side. Yeah. Yeah, just sign up for it. It's f of x, just an alternate notation. So we're going to graph, we already did a square root. We're going to do another one, but I want to focus on the domain and the range. Is a square root function one of the functions I said you have to be careful when you're dealing with domain? Yeah, it's one of the two. The other one has the variable in the bottom of a fraction. I don't think we're going to talk about those today. All right. What did we say that when you write a square root, whatever you put right here has to come out to a certain number or higher? What number is that? Yeah?
0 or higher.
Got to come out 0 or higher. So if you're not sure how to figure that out, take your radicand, that's what's under the radical, and set it equal to 0 or higher. And that'll tell you your domain. So what's my domain in this problem? What numbers am I allowed to plug in for x? Yeah?
4 or 3 and up.
3 and up. Yeah, 'cause you could do 3.0001, that's fine. But yeah, any number that's greater than or equal to 3. So that's how you can write your answer as an inequality. Another way you can write your answer is what's called an interval. If you're picking numbers greater than or equal to 3, what's the lowest number you're allowed to pick? Yeah? 3. What's the highest number you're allowed to pick? Yeah?
There's no set value.
Okay, so what would that be?
All real numbers. Or no.
Yeah. Infinity. Now, when you say 3 is the lowest number we can pick, can we include picking 3, or do we not include picking 3? Like, is it greater than 3, or greater than or equal to 3? Yeah.
Greater than or equal. You can
Right.
pick 3.
And we talked about yesterday when we are equal to something, the book uses a bracket. And with infinity, can you ever reach it? No. So technically you can't include infinity because you can never reach it. So we always have a parenthesis. That's how you write an interval. Infinity symbols always have parentheses. Numbers can have parentheses or brackets. It depends if you're including the number or not including the number, whether it's greater than or greater than or equal to. Interval notation is probably what we want to get more used to, rather than inequalities. All right, now let's graph it, see if we can find the range. So domain is the x, range is the y's. So I still have the square root typed in, so I'm just going to change it to -3. We already figured out that the domain starts at 3 and goes up. I'm going to start at 0 just because I don't like it right on the edge of the screen. I like to see a little bit past it. We can go up to 100, that's fine. I think everything else there is fine. Just hit graph. Okay, so the range is how high and low it goes. Domain is left and right. Range is up and down. What's the lowest that it looks like that graph goes on the y-axis? Yep.
0.
Yep, it does. It hits if you plug in 3. 3 minus 3 is 0, and the square root of 0 is 0. So you do hit 0 when x is 3. Okay, so the lowest is 0. What's the highest that that graph is going to go? Not the highest that you see on the screen, but if you could zoom out forever, how high would it go? Yeah. Infinity. Never stops going up. So the range here is every number from 0 and up. Or if you want to write it as an interval, 0, including the number 0, going up forever. So there's your domain and range. Let's try one more of those. Let's do B. We're not going to do it. I want to do B because I don't think I've shown you where the absolute value bar is on the calculator. Okay, so to do absolute value bars, you have to press the math button. Okay, the math button is the third one down on the left-hand side. And then at the top, you're going to press the right arrow, and you're going to go over to number. The very first option under number is ABS. That's where you find absolute value. So you go to math, number, and then it's the first option. If you hit enter, you should get those vertical bars. Yeah.
How do you get, like, what button do you press to get to there, though?
You press math, number, and then absolute value. Now I have double absolute value. Okay, and we're just going to type in x squared minus 4. Now before I hit graph, does the absolute value of x squared minus 4 have a square root in it? No. Does it have a fraction that has a letter in the bottom? No. So then what do you think the domain is going to be? What kind of numbers am I allowed to raise to the second power and then subtract 4 from? Yep.
All real numbers.
All real numbers. So the way you write all real numbers is negative infinity is the lowest number you can pick. Positive infinity is the highest. And you use parentheses because you can't include those. You can never reach them. All right. Now we've played with the window a little, so let's do zoom 6 just to reset it and see what this looks like. Okay, almost looks like a parabola that's been shifted down 4. But the problem is the parabola can't dip down and make a real parabola because that absolute value is like flipping it back up. It's not letting it go negative. And that's why this part looks the way it does. So what does the range look like there? What does it look like the lowest value we hit is? And then the highest value. Yeah. And do you think we hit 0 or we don't hit it?
We hit it.
Yeah, we do. You hit it twice. You hit it when x is 2, and you hit it when x is negative 2. Yep. So the range is as low as 0 and never stops going up. Any questions on that? Make this bigger. Okay. All right, so the second to last thing is what it means to evaluate. When you see the word evaluate, it means to take whatever number, letter, symbol, whatever they give you, and plug it into the formula for the variable. So we're going to try evaluating a few different things. So the first thing they want us to do is plug -2 in to the F formula. It's the only formula we have. Plug that into the F formula everywhere that you see an X. Okay, so the first one, you would do just like this. And those parentheses are important. If you don't put a negative in parentheses on the graphing calculator when you square it, it won't do it the right way. So whenever you have a negative number, we're going to put it in parentheses. And I'm sure people could figure this out, but I just want to show you how to do it. Just like that. So when you plug in -2, you get 5. How about when you plug in 3? When you plug 3 in for X, what will you get? Yeah.
10.
Yep. 3 squared is 9, plus 1 is 10. And how about if you plug in A? What will you get if you plug in A? Yeah.
A squared plus 1.
Yeah, just A squared plus 1. So that's what it means to evaluate. Plug in whatever they give you for X and simplify. Okay. Any question on that? Okay. All right, so the last thing. I already mentioned this to you, but just to kind of put it up on the board formally. So not everything that you can graph is a function. And in Algebra 1, the simplest way they explain what a function is basically relating it to the vertical line test. If I type in y equals, I can't do plus or minus square root of x on the same line. I have to do it on 2 different lines on the calculator. But if I graph that, you can just watch what it looks like. That's not a function. That's because when x is 4, I have 2 different values I can go to. I can go to +2 and I can go to -2. So for that one input, there's 2 outputs. And because that happens, we say it fails the vertical line test. So the vertical line test basically is kind of an Algebra 1 way to explain if you draw an imaginary vertical line and it hits your graph more than once, it's not a function. So circle, not a function. How about something like this? Would that be a function or not a function? Yeah. Yeah, that's a function. If you draw a vertical line, it never hits it more than once. A horizontal line does. That's a little different. But a vertical line never hits more than once. So any questions on the vertical line test? Okay. All right, so I need to double check the homework because I think there was a question I was supposed to cross off. Page 20, that's the first thing we did, like finding the car rental problem, making an equation, that kind of stuff. see. Oh, it might be okay. That's fine. Some of it is just things to do on the graphing calculator, and there's nothing to show on paper. So keep that in mind. 13 is okay. Yeah, no, that's okay. Right, so that'll be the homework. Remember that is due Tuesday. So we'll go over that first thing on Tuesday. And then, because we have Monday off, we're going to probably have our first test the week we come back from shop.
That's right, I forgot, Monday's Tuesday.
Yeah, Monday's a So we won't have our first test till Monday, come back, till Friday, come back after